Assalamualaikum. My name is Imran Azri bin Azzaruddin, and my metric number is B0121101887. I will explain about how to solve the question number 1. The question is find the temperature at the hottest and coldest point on the electric burner plate. First, determine all the partial derivative, which is first derivative Tx and Ty, and second derivative Txx, Txy, and Tyy. Then for the second step, we must obtain the critical point. Tx is equal to 0 and Ty is equal to 0. Tx equal to 0, we get the value of x is equal to 2. And then substitute the x equal to 2 into Ty function. And we get y is equal to 0. Then we get the new critical point, which is 2, 0. After that, for the next step, we must evaluate the second partial derivative Txx, Tyy, Txy, and Gab. First, we test at the critical point at 2 and 0. For Txx, we get -2. For Txy, we get 0, and Tyy, we get -4. To find G, we must arrange Txx, Txy, and Tyy in matrix form. This is Txx, Txy, Txy, and this one is Tyy. Then the value of G we get 8. When G is greater than 0 and Txx is lower than 0, this point will declare as local maximum value. Then for the next critical point is 1 and pi/4. For Txx, we get -1.4142 and G1. The G value is greater than 0 and Txx is lower than 0. And then the condition is local maximum value. Same with critical point 3 and pi/4. The Txx value is lower than 0 and G is greater than 0, and it's also local maximum value. Same as critical point is 2 and pi/4. The Txx value is lower than 0 and G is greater than 0, and it's also local maximum value. For critical point 1 minus pi/4, Txx value is greater than 0 and G is greater than 0, and it is a local minimum value. For 3 and minus pi/4, Txx is also greater than 0 and 1, and G is 1, which is greater than 0, and it's also local minimum value. Same with 2, same with point 2 and minus pi/4. The condition is local minimum value because the value of G is value of G and Tx is equal than 0. Okay, to know what is the hottest temperature is, we must compare the all local maximum value, which point have the highest value, and from the calculation, we know that at point 20, the value is 4. That is 4 degrees Celsius. To find the coldest temperature is compare all the local minimum value. Which point get the lowest value, and we find that when at point 2 and minus pi/4, the value is -2.828 degrees Celsius. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Mohd Syahmi bin Hamssin, namometrik B0121101177. Hari ini saya akan menunjukkan cara-cara untuk menyelesaikan question number 2. Question number 2 ni, the central of solid can be determined by using this given formula below. So formula dah diberi, so daripada soalan ni kita dah tahu ini soalan berkaitan dengan triple integral. So bounded above the spiral radius 4. So dia bagi kita radius 4 z x kuasa 2 y kuasa 2 punca kuasa. So dia minta untuk cari central of the solid C. Jadi dengan radius 4 dengan kon ni kita dah tahu untuk nilai R dia di sini 0 hingga ke 4, lepas tu untuk nilai theta dia 0 hingga ke 2 pi. Untuk mencari nilai Z, berdasarkan apa yang dia bagi ni, Z sama dengan punca kuasa X kuasa 2 tambah Y kuasa 2. So, X kuasa 2 tambah Y kuasa 2 bersamaan dengan R. Jadi, kita boleh dapat nilai, di situ Z hilangkan punca kuasa ni, dan kita dapat R. Okay, next. First step sekali kita perlu cari dia punya volume bersamaan volume berdasarkan formula yang diberi. So volume ni dia punya formula untuk volume. So nilai untuk limit tadi kita dah dapat 0 hingga 2 pi, 0 hingga 4 R dengan tu 1 dz R dr d theta. So first kita integrate untuk Z dulu. So Z ni tak ada nilai apa, kita just put Z. Lepas tu limit 4R. So kita masukkan 4 tolak R, R dr d theta. Lepas tu kita darab masuk R ni jadi 4R tolak dengan R kuasa 2. Okay, untuk next pula kita integrate untuk dr pula. So 4R kuasa 2 per dengan 2 tolak dengan R kuasa 3 per dengan 3. So daripada sini kita masukkan nilai limit dia 4 ke dalam R ni. Lepas tu 4 ni ke dalam ni kosong, dia tak ada nilai apa. So kita dapat nilai last sekali untuk ni ialah 32 per 3. So last sekali kita integrate untuk theta. Untuk theta just kita wujudkan theta tu. Lepas tu 32 per dengan 3. Lepas tu darab dengan nilai theta 2 pi ni. So kita dapat jawapan akhir 64 per 3 pi. So ini first step kali kita find the volume ni. Okay, untuk next step kita baru cari untuk MYZ. MYZ ni bersamaan dengan X dV. So untuk X, kita tahu untuk X tadi saya dah tulis kat atas ni, X bersamaan dengan R cos theta dan Y bersamaan dengan R sin theta. So sama juga macam tadi, limit kita sudah tahu 0 hingga ke 2 pi, 0 hingga 4 dengan R hingga 4. So R cos theta dz R dr d theta. Okay, lepas tu kita integrate Z, kita just wujudkan Z ni. Okay, lepas kita dah wujudkan ni, kita gantikan nilai 4 mula-mula. Lepas tu cos theta, lepas tu nilai yang kedua pula, nilai Z ni R cos theta. Ini dah dapat R kuasa 2, R kuasa 3 ni sebab saya dah masukkan sekali. R yang di luar ni, saya dah masuk sekali. Okay, next step. Lepas tu kita dah tahu penyebut dia ini cos ni, cos sama. So kita boleh asingkan dia. Jadi 4R kuasa 2 tolak R kuasa 3 cos theta dr d theta. Okay, yang seterusnya kita integrate untuk dr pula. Okay, dr kita ambil 4R kuasa 3 per dengan 3 tolak dengan R kuasa 4 per dengan 4. So dari sini kita masukkan nilai saja. Kita masukkan nilai 4 ke dalam ni dan ke dalam R. Dan kita dapat 256 per dengan 3 tolak dengan 64 cos theta d theta. So jawapan dia, bila lepas tolak ni kita dapat 64 per 3. 64 per 3 tu limit 0 to pi cos theta d theta. Okay, yang last sekali kita integrate untuk theta pula. So untuk integrate untuk cos theta kita akan dapat sin theta. Okay, sin theta kita just masukkan 2 pi ke dalam sin theta ni. So sin theta 2 pi tolak dengan sin kosong. Lepas tu kita akan dapat kosong. Lepas tu 64 darab dengan 3. 64 per 3 darab dengan kosong tu kita dapat kosong. Okay, so untuk MXZ pula Y. Lepas tu dV. So Y tadi nilai dia R sin theta. So sama macam tadi juga, limit dah bagi 0, 2 pi, 04 R hingga ke 4 R sin theta dz R dr d theta. Okey, lepas tu kita integrate Z dulu. Okey, Z kita masukkan, kita wujudkan Z R sin theta 4R, limit dia R dr d theta. Okey, lepas tu kita just masukkan 4R cos 2 sin theta tolak R cos 3 sin theta. Okey. Macam dapat cos 2 ni sebab saya dah masukkan sekali, nilai R ni saya dah dapat masuk. So dapatlah nilai untuk dz integration ni. So kita integrate untuk next step. Okey, maafkan. So lepas ni kita dah tengok penyebut dia sama, sin. So kita boleh asingkan. Okay, lepas kita asingkan tu kita just integrate dr pula. Okay, 4R kuasa 3 per 3 tolak dengan R kuasa 4 per dengan 4. Okay, lepas tu kita masukkan nilai 4 ke dalam R. Kita masukkan dan kita dapat 256 per 3 tu kita masukkan nilai 4 ke dalam samaan ni. Tu kita dapat 64. Kosong, diletakkan kosong. So last sekali kita dapat 63 dengan 3. Okay, untuk last kali ni dia sin. Sin ni kalau integrate dia, kita akan dapat negative cos. Okay, negative cos kita masukkan nilai dia 2 pi. 2 pi. Negative cos 2 pi tolak dengan cos kosong, kita akan dapat nilai kosong dan 64 dengan 3 darabkan kosong. So kita dapat kosong. Okay, lepas kita dapat semua nilai tu, last sekali kita cari Z pula. Okey, Z macam biasa Z dV tak ada apa, limit dia sama saja. Lepas tu kosong 2 pi kosong 4 tu kita integrate Z kosong 2 per 2 4R. Tu kita gantikan nilai itu saja. Masukkan nilai 4, kita dapat tu R kuasa 2 dapat nilai 8, lepas tu R kuasa 2 per dengan 2 R dr d theta. Lepas tu kita darab masuk nilai R ni jadi 8R tolak dengan R kuasa 3 per dengan 2. Okey, lepas dah kita settle integration untuk dz punya, kita cari untuk dr pula. Okey, untuk kita integrate dr 8R kuasa 2 per dengan 2 tolak R kuasa 4 per dengan 8. Kita dah tambah 1, tu kita darab bawah ni. Okey, lepas tu kita just masukkan limit dia lah sekali. Kita masukkan dalam ni 4 kuasa 2 per dengan 2 tolak dengan 4 kuasa 4 per dengan 8. Lepas tu kita dapat 64 tolak dengan 3 per 2 di theta. So last sekali 64 tolak 32 dapat 3 per 2. Iaitu kita integrate untuk theta pula 32 theta. Lepas tu limit dia kosong 2 pi. So kita dapat last sekali jawapannya 64 pi. Okey, lepas kita dah dapat ke semua nilai MXY, MXZ dengan MYZ, barulah kita boleh masukkan di dalam formula yang diberi ini. So untuk mencari nilai X ni, dia MYZ per dengan M. MYZ kalau kita tahu tadi, dia kosong bagi nilai M yang volume first tadi, 64 per 3, kosong bagi 64 per 3, dia kosong. So untuk MXZ dia still kosong, lepas tu bagi dengan nilai yang kita dapat mula-mula tadi 64 per 3, so still kita dapat kosong. Dan akhir sekali Z kita dapat nilai 64 pi, 64 pi, betul kita bahagi dengan 64 per 3 pi. So akhir sekali kita dapat jawapan 3. So untuk final answer dia center of the solid G, kita dapat X, Y, Z ni ialah 0, 0, 3, 0, 0, 3 di sini. Okey, itu ialah cara-cara untuk menjawab soalan nombor 2 triple integral daripada saya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Yusman. My metric number is B0121101880. So today I want to show you how to solve question 3. verify Stokes theorem for the vector field equal to open bracket x square minus y square close bracket I plus 2xyj. In the rectangular region, and the xy plane bounded by the line x from negative a to a and y from 0 to b. So describe your solution by sketching the rectangular region and suitable curve along the region, and explain how integration c f dot dr f dot dr equal to double integration s curl dot nds. So this is the sketching for the equation. Since fxy equal to xy minus, x square minus y square, and g xy equal to 2xy. By using the green theorem, integration c f dot dr equal to integration c fx y dx plus gxy dy. So double integration region d over dx and minus df over dy dA. So the double integration, the limit of x equal to negative a to a, and the limit of y is from 0 to b. So we substitute the value of g and f into the equation. After that, we differentiate. So we got a 2y plus 2y dy dx. So the integration of x from negative a to a, and integration of y is from 0 to b for xy, for y dy dx. So we put the value of 4 to the outside. So we only integrate dy with the limit 0 to b. So we got the b square over 2 dx. So after that, after that, we integrate x into the equation. So we got the b square times a minus b square times negative a. So we got the 4ab square. So for the curl of f by the double integration as surface curl dot nds. So the curl f equal to 4yk. As you can see, we use a cross product for this equation, so we go 4yk. So for the surface as n dot nds equal to k. So after that, curl f dot nds equal to k. So r dot h dot s equal to double integration surface with curl dot nds. So same as we use a green theorem, we use a double integration of value of x equal to negative a. Limit of x is negative a to a, and limit of y from the 0 to b, function of 4y dy dx. So we integrate the y first. So we got the b square over 2 dx. And after that, we integrate the dx with the limit negative a to a. So we got the same answer as the green theorem. So this equation has been verified. As you can see, integration c f dot dr equal to double integration of curl dot nds equal to 4ab squared. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Hakimi Azhar. My metric card number is B012-1100X6. I would like to present question 4 for this assignment. Throughout week 1 until week 14 of Engineering Mathematics 2, we chose divergence theorem as our topic and was given to produce an essay about the use of divergence theorem in electrical engineering. This theorem is an important in physics and electrical engineering mathematics. mainly in electromagnetics and fluid dynamics. Start off by using the first one, which is the Gauss theorem, which connects a vector field flux via a closed surface to the field divergent in the contained volume. Divergent theorem is also a mathematical statement where the absence of matter creation of distraction. The density within a region of space can only change by enabling matter to flow through or out of the region through in boundary. We can use water turbine as an example for outward flow. It operates primarily with rotary motion, like wheels and turbine that undergoes energy conversion from kinetic energy to mechanical energy. An associate generator converts mechanical work into electrical power. The outward arrow has a magnitude and a direction, which is known as a vector field with F equal xi plus yj plus zk.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Mohd Amirul bin Shah, matric number B0121101883. So I'm going to explain about question number 4. For question number 4, we have chosen to discuss about divergence theorem that was covered in engineering mathematics 2, week 14, and it uses in electrical engineering. The divergence theorem is an important mathematical concept that is used in electrical engineering. It is a theorem that states that the surface integral of a vector field outward normal flux over a closed surface equal the volume integral of the field divergence over the volume enclosed by the surface. Because it can be used to calculate the electric field around a charged body, as well as the electric flux through a closed surface. This theorem is useful in electrical engineering. Divergence theorem can also be used to calculate the potential differences between 2 points in a field. By calculating the electric field line integral across the path joining the 2 points, this may be done. The difference between the potential at the two sides is equal to this integral. Finally, the electric field produced by a time-varying current can be calculated using a divergence theorem. To do this, one must take the line integral of the electric field along path that connects the point at where the current begins and terminates. The change in the electric field over the path is represented by this integral. In conclusion, the divergence theorem is an important concept in electrical engineering. The potential difference between 2 points in a field, the electric flux through a closed surface, and the electric field produced by a time-varying current can all be calculated using it. This theorem is an effective tool for constructing electrical systems as well as comprehending the behavior of electric fields and fluxes. That's all. Thank you.